Hello everyone. In this video, we are going to prove that root 3 is an irrational number. So whenever we are supposed to prove root of any number, that may be x, is a rational number, we will use one theorem. What is the theorem, So you need to know two things. One is p and another one is a. P is a prime number and a is a positive integer. So let p be a prime number and a be a positive integer. If p divides a square, then p divide a also. Okay, this is what the theorem we are going to use whenever there is a kind of problem like root x is an irrational number to be proved. So we will be using this theorem only. So let's start with the given question first. So here asking us to prove root 3 is an irrational number. So first, always our first step is that we are assuming this root 3 is a rational number. So we have to assume in an inverse way. Okay. So let us assume root 3 be a rational number. So whenever there is any number is a rational number, how we can express the given number? So with p by q form, right? So here also, since this is a rational number, we can express root 3 as p by q form. So maybe some common factors are there. So after cutting the common factors, I got a by b, where this a and b doesn't have any common factor. So we can say this are co-prime also, right? So a and b are co-prime. They don't have any factor other than 1 in common, right? That is what co-prime na. So they don't have any factor other than 1 in common. So this is what first step. So what is our first step? First we have to assume in an inverse way. If they are asking us to prove irrational number, first we need to consider the given number is a rational number. Since this is a rational number, I can express this in a fraction format p by q, where that can be reduced to a by b, where a and b are co-prime. And what is the meaning of that? They don't have any common factor other than 1. And one more very important thing is what? B is not equal to 0. This also. Okay, this is what our first step. Now our second step is, so what you got? Root 3 equal to a by b. So what we need to do? Squaring on both the sides with this equation. So I'm going to square on both the sides of this equation. So what we will be getting after squaring on both the sides? So root 3 the whole square and a by b the whole square. Root 3 square we will get 3, and over here a square by b square, right? So again we can move this b square to this place. Yeah, so can I write b square equal to a square by 3? So what is the meaning b square equal to a square by 3? So what is 3 over here? Can I say it's a prime number? Yes, so 3 can divide a square. So what we are concluding here, 3 divides a square. So here we are going to use this particular theorem. If a prime number divides a square, then the prime number divide a also. If 3 is a prime number, 3 divides a square, then 3 divide a also. Understood? So 3 divide a. So still, so these you can consider as a second step, and just mark this equation as 1. So now what is our next third step is, we are going to equate a to b of some other variable. So can I assume a equal to 3c? So I'm going to substitute the value of a as 3c in equation 1. So can I do that? So over here it is b square, and instead of a we are going to substitute 3c, but here it is a square, so put the square divided by 3. So if you solve, what you will be getting? 9c square by 3. Again 3 and 9 will get cancelled, which is 3c square. So what we got? B square equal to 3c square. So can I move this 3 to the LHS? So what we will be getting? B square by 3 equal to c square. So now over here 3 is a prime number. So 3 divides b square, then 3 divides b also, right? So based on the theorem, so first we stated a theorem, right? Based on that, if 3 divides b square, then 3 divides b also. So now what we have concluded over here in our second step, we concluded 3 divide a. And over in the third step, what we have concluded, 3 divides b. But initially what we defined, a and b are co-prime. So a and b are co-prime. They doesn't have any common factor. But now we have proved that 3a also having a common factor 3 and b also having a common factor 3. So now what I'm saying, both a and b are having a common factor 3. But this contradicts the fact that A and B doesn't have any common factor other than 1. So a contradiction arises on our assumption. So what we have assumed is wrong. So root 3 is an irrational number. This is how we need to do this problem. So we need to write the statement over here at the last. So I can write the statement as both A and B are having a common factor 3. This contradicts our assumption. This contradicts our assumption. So, root 3 is an irrational number. So, this is how we can conclude our answer. Hope you understood. Do subscribe for more videos. Thank you.